All right, today we're going to look at the number of solutions to systems of equations. So just like when we're just solving an equation, there's instances where we might have a different number of solutions. We could potentially have one solution, we could have no solution, and we could have infinite solutions. So let's go ahead and take a look and see how each one of those scenarios might happen. So when we're looking for solutions to systems of equations, we're going to be looking for the point where those two lines cross over each other. So in our instance where we have one solution, we can see here that this line crosses over the other line one time. So if we were to describe these two lines and we were going to look at them, we'd say, all right, the slopes of these two lines are different. We have two different slopes. Our first line has a slope of -1/2. Our second line has a slope of 3/4. So our slopes are different. Now, in addition to our different slopes, we also happen to have different y-intercepts. They don't always have to be different, but in this case they are. We can see that our y-intercept is +3. Our y-intercept of our second line is +0. So we have two different y-intercepts. So when we're looking for an equation that has one solution, we mostly want to make sure, hey, these lines have to have different slopes because the two lines have to cross over each other. So that's our first type of solution. It's when we have equations that have just one solution with different slopes. Now our second scenario, number 2, we can see that we've got a scenario here where there is no solution. So remember, we're going to try and find where do these lines cross. So if we look at this line, we follow it all the way down, we'd see, all right, this line does not cross over the other one. If we were to describe these two lines, we might say that these two lines are parallel. Parallel lines never cross over each other, which means that there is going to be no solution. There's no point that these two lines share. So if we were to describe these two lines looking at our two equations, we would say, all right, we've got our slopes. This one has a slope of -1/2. This one has a slope of -1/2. So we wouldn't say that these are different, but we would actually say that these slopes are the same slope. Now, our y-intercepts, however, if we go ahead and look at those, we can see that, hey, the y-intercepts of these lines, one of them is +3, one of them is -3. So we would say that we have different y-intercepts. All right, so when we have parallel lines, meaning that we have lines that have the same slope but different y-intercepts, we're going to end up with no solution. Now our third scenario, this one doesn't happen very often, but it happens enough that we're going to have to talk about it. So our third scenario here is where we have infinite solutions. So infinite solutions are where we've got two lines that are right on top of each other. We would call those coincident. So coincident lines are two lines that are right on top of each other. And we can see here on the end, it's a little hard to see, but you can see that those arrows are doubled up, showing us that we have two lines right on top of each other. So let's go ahead and look at what the equations for those two lines are. We can see that, all right, if we have the slope of those two equations, we do not have that right on this paper here. The slope of those two equations should be exactly the same. We should have y equals -1/2. So -1/2 means that those two lines are going to be right on top of each other. +3, they're both going to cross over the y-axis at the same point. So the slopes are the same. The y-intercepts are the same. So when we have two lines with the same slope and the same y-intercept, that means that we're going to have an infinite number of solutions. Every single point on this graph we could circle and say, hey, that's a point where those two lines share. So now let's go ahead and move on to our next video. We're going to go through some examples together.